Welcome everybody. It's Ramachandra from CIVIL-MECH-MATHS Concepts. CIVIL-MECH-MATHS Concepts. And in this lecture of Structural Analysis 6, I'll be dealing with moment of inertia of a semicircle. In the last 5 lectures, I have developed the concepts regarding the forces, members, and then beams. Now, in the last lecture, I have done moment of inertia calculation using calculus for sine wave. Now, in this lecture, I will be taking up semicircle. Let us take a semicircle whose radius is r and the origin lies at one end of the diameter on x-axis and x coordinates vary from 0 to 2r. Y coordinates vary from 0 to r. Here height h of the curve is equal to the radius of the curve because it is a semicircle. Circle is uniform on 360 degrees rotation. Hence, semicircle, we can say height of the semicircle is radius of this semicircle. And the diameter of the semicircle is 2r. What we are supposed to find out? We are required to find out the moment of inertia. For finding the moment of inertia, what we require? One is, first step, as I explained in the previous class. Please see that in the sine wave I have detailed what should be the procedure for finding the moment of inertia. In 5 steps I have completed it in a very detailed manner. Please look into that. First we have to calculate the area, then first moment of area we have to calculate. Next we have to calculate the center of gravity of the shape. Fourth step is finding the moment of inertia Ixx about x-axis, and fifth is moment of inertia about center of gravity. The definition of center of gravity and x-axis may differ from author to author. This is what I have taken as a standard form. Even in sine wave also I have explained in the similar way. So that we'll go ahead with this. Keeping above in view, we'll start solving step by step for moment of inertia of a semicircle about x-axis and also about center of gravity. Now, the major challenge is in finding the area and also moment of inertia. Area you may be knowing, area of a circle is equal to pi r square. But in this particular case, we will not be going with the literal value of the area, we will be finding the value of the area. First step, because I am not here to give you the values, I want to develop the concepts. For developing the concepts, we require a procedure. Let us follow a procedure to find the area of a semicircle. Let us draw a semicircle. It will be like this. Let us say this semicircle, this is the radius, height is also radius as I told you earlier. This is also radius, or this is origin O, this is A, this is B, and this is C. Let us try to find out the area OAC. What we have to find out? Area OABC. What we require? We require we have to find out area covered in the loop OABCO. OABCO. This is the loop area which we have to find out. Now, area of OABCO is equal to 2 into area of OACO. From symmetry, let us say we are finding out this area OACO. OACO area, when we double it, then we will get the total semicircle area. Now, to get the OACO area, what is the function of y here? Function of x? Y should be some function of x to find the area. That was the concept developed in the previous example for sine wave. You can see the last lecture of mine in which I have developed this concept perfectly very well. You can see that. You can grasp it. And y is equal to function x. What is the area? Area is equal to double integral of dy dx, which is nothing but integral of dy dx. That is equal to integral of y dx, because integral of dy is y. Y is the function of x. That is equal to integral of function of x dx. This is how we have developed the concepts in sine wave moment of inertia calculations in the last lecture. Now, here for a circle or for a semicircle, for uniform quarter circle, what is that formula? It is governed by trajectory y square is equal to r square minus x square. Or equation of the circle is x square plus y square is equal to r square. This is the equation of the circle, from which we got the answer y is equal to square root of r square minus x square. This is what is the value we have got. Now, let us try to substitute in this. What is the area? Total area integral function x dx. Here we are not talking about the limits as of now. This will be equal to integral of square root of r square minus x square dx. Now once it is written like this, we can put the limits as 0 to 2r. It's not a that is the integral to solve. It may look simple, but it's not a that is the integral to solve. Now for this what we have to do, instead of going into the Cartesian coordinate system, we will use r and theta, which are the polar coordinate system. I will tell the difference between Cartesian and polar. Let us draw one x-axis and y-axis. One point is here, point A. Please try to understand this. It has coordinates x and y as Cartesian coordinates. The same can I write, for example, it is origin O. I am connecting O and A, and I will call this distance as r. And the angle with the x-axis, I will call this angle as theta. Then, can we define this point A with the help of r and theta? Yes, definitely I can define. The same can be defined in polar coordinates as r and theta. If I know the value of r, distance of the point from origin O, and the angle, the vector r makes with the x-axis in anti-clockwise direction, once that theta is known, then I can easily find out the position A, point A. Now, let's draw a perpendicular here. On x-axis, this is x, this is y, on y-axis. A perpendiculars are drawn. Now, this distance is r cos theta. I have explained about this resolution of vectors even in my previous classes, structural analysis, initial classes, 1, 2, 3, 4, 5 lectures, and also in the gate engineering mathematics, I have explained the vectors, how to resolve horizontal and vertical components. This is r sin theta. Please refer to my lectures from the same channel, Gate Engineering Mathematics. Mathematics by IIT Alumni. You can type this in Google or somewhere in YouTube, you will get those. In that, I have in detail explained about the vectors. About 50 videos are released by me. As of today, from civil, mech, maths, concepts. For developing the concepts in civil engineering, mechanical engineering and engineering mathematics, I started this channel. You can refer to them. You will understand better. In detail I have explained. But however, here also I am explaining to you. Y is r sin theta. This I can write it as r sin theta. X as r cos theta. Now, when the coordinates are put in r theta form, it is polar form. Can I write a point A? Please understand the concepts first. Can I write the point A instead of xy? Can I write it like this? R cos theta, r sin theta. A point A. R cos theta is x component of this point when projected on the x-axis, r sin theta when it is projected on the y-axis. Now, when we consider only, please try to understand. I am taking little bit time, but try to understand and you will get the, once you get the concepts, you can apply for any curve. Sine curve I have clearly explained. Now I am explaining the semicircle. This portion only we are taking. We are doubling it so that we will get for the semicircle. This is only quarter portion of the circle. Now, when theta is 0, here what is the value? Here you see it is the point O. When theta is 0, that means when the line is flat, x is equal to r. When theta is 90 degrees, x is equal to 0. That means theta varies from 0 to 90 degrees and x varies from 0 to r. I have taken on a numerical values. Or else you can take this way also. This is one way of expressing, and another way of expressing also this way. Please don't get mathematics can be expressed in any manner, any way. Somebody may ask, why should I take theta from the horizontal axis itself? Let me take theta in this way. Why not? When theta is equal to 0, what happens? This line moves in this direction. Theta is equal to 0 means x value will be 0. Theta is equal to 0 implies x is equal to 0. When theta is equal to pi by 2 or 90 degrees, that means when theta becomes 90, this way x is equal to r. When you take this way, why I am explaining both the means, the reason being, in the examination, we can't say how the theta is measured. Either theta can be measured from the vertical axis or it can be measured from the horizontal axis. Either way it is possible. So we have to be doubly sure, we have to be equipped with solution for both the situations. Now, here also the same thing holds good. Theta varies from 0 to 90 degrees and x varies from 0 to r. R is the radius when you consider this portion only. Please try to understand this concept clearly. Now, if you take here in this, what happens? X is equal to r sin theta, y is equal to r cos theta. Here x is equal to r cos theta and y is equal to r sin theta. From these equations also we can say when theta is equal to 0, it implies x is equal to r because cos 0 is 1 and y is equal to 0. Here, when theta is equal to 0, x is equal to 0 and y is equal to r. You just see. When theta is equal to 90, here, please try to understand. X is equal to r, y is equal to 0 because cos 90 is 0. Here, if theta is equal to 90, x is equal to 0 because cos 90 is 0, y is equal to r. The only numerical values are changing. The concept is not changing. The variation of theta is varying from 0 to 90 and x is varying from either r to 0 or 0 to r. In either way. Here also theta is changing in this way. When you take the vertical angle theta, theta is changing from 0 to 90 and value of x is changing from 0 to r. If you feel This system is convenient. Either way you can express absolutely, there is no problem. Let us take something like this. Why not? Let me take this one as the sample for me. In mathematics, we can take anything, but we arrive at the same destination. You take any path. In mathematics, we get the answers. Similar way. Same answer. 2 into 2 is equal to 4. It will be. But the value of 2 can be 5 minus 3 into 6 minus 4 also. Ultimately answer is 4. Either way we can go. That is the essence of mathematics. That's how we have to do mathematics. We have to apply, experiment, and we have to see. So that what happens, we will exactly get the answer or not. Once we get the correct answer, that means whatever way we do mathematics, we get the answers. Now, with this, can we say 90 degrees as pi by 2? Because we are doing in polar means, let us convert everything into radians. 90 degrees is equal to pi by 2. 180 degrees is equal to pi radians. Radians and everything also I have explained how to calculate the radian. What is the value of radian? It is approximately equal to 57 degrees. 1 radian is equal to approximately, that I have already derived and shown in my previous classes, previous videos, in almost all 50 videos which I have released. You can refer to them. Now, what are the boundary conditions? Regarding boundary conditions also I have explained in the previous class. What are the boundary conditions? Theta varies from 0 to pi by 2. These are the limits. X varies from 0. When theta is equal to 0, x is equal to 0. When theta is equal to pi by 2, x is equal to r. These are all our boundary conditions. Now, with these boundary conditions, using the equation previously what we have written, area is equal to integral of function x dx, that is integral of 0 to 2r square root of r square minus x square dx. Then area can we do like this. Instead of directly taking total semicircle, for quarter circle, area for quarter circle is equal to integral 0 to r square root of r square minus x square dx. We will do like this. And area of a semicircle is equal to 2 into area of a quarter circle, that is 0 to r square root of r square minus x square dx. Double integral we have taken out by replacing the value of y. Function x. Y is equal to some function x. Now, area is equal to semicircle area we are talking, because that's what we have to find out. 0 to r square root of, this step you please carefully understand. If I already know this, in this condition I have already chosen which one? This one. X is equal to r sin theta and y is equal to r cos theta. That I have taken with vertical axis. X is equal to r sin theta. implies, let me do differentiation on both sides. What is dx by d theta? R into cos theta. What is d by d theta of sin theta? Is cos theta. D by d theta of sin theta differentiation. It's very simple. Please remember this. Another one, d by d theta of cos theta is equal to minus sin theta. These you people please remember. Now, if x is equal to r sin theta, then dx by d theta is equal to r cos theta. Then, when you do the, when multiply, when you take d theta on the right hand side, what happens? Dx is equal to r cos theta into d theta. Because my integral is in the Cartesian coordinates in dx, I want to remove the dx and replace with theta, r and theta, because I am switching over from Cartesian to polar. In Cartesian it is xy, in polar it is r theta. I want to convert into r theta so that it will be convenient for me to do the integration. In Cartesian it is very difficult to find the integration of this. In polar it will be very easy for me to do. Choice is yours. You can take, but better to understand the polar system also. Then what will be the area? 2 into, when we convert everything into theta, the limits also will go into theta. When r is equal to 0, what is the theta value? Theta is 0. When r is equal to r, what is the value of theta? Theta is equal to pi by 2. When x is equal to 0, theta is equal to 0. Please see the limits here. When x is equal to 0, theta is 0. When x is equal to r, theta is pi by 2. This is what I have used here. Here r I have replaced with pi by 2, that is angle. Here 0, when x is equal to 0, angle is pi. Now, please try to understand the concept, how to develop the polar equations. Now, square root of r square minus x square means what is x? R sin theta. Then I will make it square root of r square minus r sin theta whole square. Into what is dx? Dx is replaced by r cos theta d theta. This is the equation. It's a simple equation, not a very big equation. Please only we have made the what you call substitutions. Now, can we take out r from here? Square root of r square is r. R square root of 1 minus sin square theta. Can we write this one like this? Into r cos theta d theta. That is equal to integral 0 to pi by 2 r into square root of 1 minus sin square theta is equal to square root of cos square theta into r cos theta d theta. That is equal to 0 to pi by 2. R into r is r square. Cos square theta square root is cos theta. Cos theta into cos theta d theta. That is 0 to pi by 2. R square cos square theta d theta. that is equal to r square is a constant. We are not changing the radius of the circle. This we have to multiply with 2 everywhere. 2 into r square integral 0 to pi by 2 cos square theta d theta. In the last sine wave moment of inertia in the last class, structural analysis 5, in which I have explained about the moment of inertia of a sine wave. The lecture name is Moment of Inertia of Sine Wave. From my channel CIVIL-MECH-MATHS Concepts. You can view that and you can understand how cos square theta or sin square theta are converted into cos 2x and sin 2x. What is cos square theta? Cos square theta is equal to 1 by 2 into 1 plus cos 2 theta. Then can we do this here? 2r square integral 0 to pi by 2 half into 1 plus cos 2 theta d theta. It's a simple now, very simple. That means area of the semicircle is equal to 2r square into 1 by 2 into integral 0 to pi by 2 1 plus cos 2 theta d theta. Another also I have told you in the last class, integral of cos ax dx is equal to 1 by a sin ax, which I asked you to remember. You see here also we got the application of it. In sine wave also we have got the application of it. Now let us apply this here. Area is equal to r square into integral 0 to pi by 2 1 d theta plus integral 0 to pi by 2 cos 2 theta d theta. That is equal to cos ax is 1 by a into sin ax. That means this is r square into, what is the integral of 1 dx? Is x. This is also I have already told you, explained clearly in the previous class. R square into 1 d theta is theta. Theta limits from 0 to pi by 2 plus cos 2 theta is nothing but 1 by a. 2 theta is equal to a, 2a. We can say 1 by 2 into sin 2 theta, values ranging from x value, theta values ranging from 0 to pi by 2. This is the final answer. Therefore, area of semicircle is equal to r square into pi by 2 minus 0 plus half into sin 2 into pi by 2 minus sin 2 into 0. That is equal to r square into pi by 2 plus half into, what is sin 2 into pi by 2? That will be sin pi. Sin pi, what is the value? Sin pi is 0. 0 minus 0. that is equal to pi r square by 2. Therefore, area of a semicircle is equal to pi r square by 2. This is the value. From this we can say area of circle is equal to semicircle into 2. 2 into area of semicircle, that is equal to 2 into pi r square by 2, that is equal to pi r square. This is the standard formula we know, but however I didn't go for the shortcut to say that area of a semicircle is pi r square by 2. I can directly write, but I did not write. I wanted to derive it, so that you will have a feel of that it is derived from calculus. Now, the first answer is area of semicircle is equal to pi r square by 2. Now, we have to find out the centroid. Now, for finding, second part is to find first moment of inertia, first moment of area, not inertia. Why we have to find out? I have explained in the previous class also, when I have dealt with sine wave, because for finding the center of gravity, the coordinate of y with respect to x-axis is equal to first moment of area with respect to x-axis, that first moment of area with respect to x-axis divided by area. What is the first moment of area? That is, we have discussed in the previous class, that is integral, double integral y dy dx. What is the area? Double integral dy dx. This is the center of gravity, y coordinate with respect to x-axis, measured from the x-axis. This is a very, very important formula which I have told you and explained you in the last class. Now, with this concept, we have to first find out the first moment of area, because area we have already found out. From there we can find out the y coordinate of the height of the center of gravity from x-axis or from the base. Now, what is the first moment of area of semicircle? First moment of area of semicircle double integral y dy dx. Let's not hurry to put the limits now. This is equal to integral y dy dx. This will be integral of y dy integral is y square by 2, which I have already explained you in the previous class. Integral of y to the power of n dy is equal to y to the power of n plus 1 by n plus 1. That is from the prelims you should have understood in your higher secondary calculus courses. Now y square by 2 into dx. What is y square? What is y square here? For a semicircle, previously we considered only the quarter circle. Here we are considering the whole semicircle. We can't find out the moment and double it for the quarter circle, not like that. For every shape, it will be like this. For every shape, there will be different y coordinate. This is y bar, this is CG. Now from 0 to 2b. Here, for quarter circle, y square is equal to r square minus x square. But here it is not so. This is r. This is r. Sorry, it is not 2b, it is 2r. We have to write 2r0. It is r. Then y square is equal to r square minus x minus r whole square. This is the equation which we have to use for the whole semicircle. You just see. If you put x is equal to 0, what happens? Y is equal to 0. If you put x is equal to r, then y is equal to r. That means at x is equal to 0, y is equal to 0, and at x is equal to r, y is equal to r from this equation. That means the locus of this curve is y square is equal to r square minus x minus r whole square. We use this equation. When we considered only quarter circle, we used the formula y square is equal to r square minus x square. When we have to use for this total semicircle, we have to find out the center of gravity, then we have to use this formula. Because we are not taking quarter and doubling it, it's not possible. That's not a center of gravity. It should not be done that way. Now, y square is equal to r square minus x minus r whole square. Now, what will be the first moment? Now let us calculate. Now it will be easier. First moment of area. Because in the examination we don't know whether they ask the first moment of area, whether they ask the moment of inertia, or they can even rephrase the moment of inertia, second moment of area, or they can ask for center of gravity, or they can ask for the area. We should be ready. We should be equipped with all full knowledge. First moment of area is equal to integral y square by 2 into dx. What is y square? Y square is equal to r square minus x minus r whole square. That is integral half, let us take it out, y square dx. Y square by 2 dx, half we will take it out, half into integral. Let's not put the limits immediately now. What is y square? Y square is r square minus x minus r whole square dx. That will be half into integral r square dx minus integral x minus r whole square dx. Now we have to calculate the whole integral. When we do it with respect to this, half will be half here, r square will be r square, dx will be x, and here we can put it as 0 to 2r. 0 to 2r. When we converted everything to r, x, we can put the limits as 0 to 2r. X minus r whole square dx. That also we can expand. Minus integral 0 to 2r x square minus 2xr minus r square dx. The whole is going to give you an answer that is equal to half into integral. Let us write this also as an integral instead of this. Let us write so that minus plus will go off, r square dx minus integral 0 to 2r x square dx minus plus, because minus into minus is plus, here it will be plus, minus into minus is plus, integral 2xr dx minus integral r square dx. Here you see this r square dx and this r square dx will go off. Now ultimately we will be left with, in the next page we will write, we will be left with integral y dy dx double integral is equal to, first moment of area is equal to half into integral 0 to 2r 2xr dx minus integral 0 to 2r x square dx. 2xr dx will be x square by 2 into 2, that is x square r. This will be half into x square r 0 to 2r. This is x cube by 3 0 to 2r. That is equal to half into x square is 4r cube minus 8r cube by 3. Please try to follow me. Now this is equal to half into 4r cube by 3. This is equal to 2r cube by 3. This is the first moment of area. First moment of area of a semicircle. That is equal to 2r cube by 3. Then what is the area of the semicircle? Pi r square by 2. Now we got the second answer. To find the first moment of area of semicircle, we have already got a value. Now our next step is to find center of gravity of semicircle. Center of gravity here I mean the y coordinate measured from the x-axis, measured from the base. That's what I mean in this y bar. This is the y bar. This is what I mean. What is the formula for the y bar? Y bar is equal to double integral y dy dx divided by double integral dy dx. What is the double integral y dy by dx? 2r cube by 3 from the previous value. This is 2r cube by 3. What is this value? Pi r square by 2, which will be 4r cube by 3 pi r square. When you cancel r square here, this is equal to 4r by 3 pi. Y bar is equal to yc is equal to, it can be even called as 4r by 3 pi for a semicircle. This is how we have to find out for any given. Once you do this as an exercise, when we complete this, we never forget in the examination this value because we have done it with our own hands. Y bar is equal to yc is equal to 4r by 3 pi. If we only mug up, then what happens? You may forget in the examination. You may get confused in the examination. If r is the radius of the semicircle, the y bar yc is equal to 4r by 3 pi at a height of 4r by 3 pi from x-axis. This is the base. Why it is found out? In the beams, what happens? It is the place of neutral axis. In the neutral axis, the strain changes its sign from either positive to negative or negative to positive, depends upon the bending moment applied or moments applied or forces applied. On the neutral axis, the strain will be 0. That is the concept. For that we find out the center of gravity. Now, what is the next step? What we have to do? We have to find out as a fourth step not center of gravity, moment of inertia of semicircle with respect to x-axis. We'll find out with respect to x-axis first, and then we'll find out with respect to center of gravity. Center of gravity, full coordinates will be, this will be the center of gravity. This full coordinates will be, here it is not B, here it is R. Because this is the radius, this is the center, this is R. Center of gravity is like this. X-axis also, we have found out the value of on x-axis also, we can write. X coordinate also, because of the symmetry, from the symmetry we can write like this. This is the center of gravity. This is y bar, yc is equal to 4r by 3 pi, whereas this is x bar is equal to r. That means x bar is equal to r, y bar is equal to 4r by 3 pi. Center of gravity will be r 4r by 3 pi. Full center of gravity, both the coordinates are r 4r by 3 pi, where r is the radius of the circle. Please remember this. When it is kept base on the x-axis, when base is kept on the x-axis. Then, moment of inertia of semicircle with respect to x-axis. What is moment of inertia? From definitions which I have given in the last class, moment of inertia is equal to second moment of area. Second moment of area. That is equal to double integral y square dy dx. Please try to understand this. Y square dy dx. This can be written as, for the whole semicircle, what is the value of y? Y square is equal to x square minus r minus whole x square. For a semicircle, for whole semicircle, it is the equation, not for quarter circle. Okay? Now for whole semicircle, this is the equation. Now, what will be moment of inertia? Ixx is equal to double integral y square dy dx. This, it is not that this equation is not for quarter circle, it is also useful for quarter circle, but we have not used. I told you 2 into 2 is equal to 4 need not be shown in a particular way only. We can show in any way, like that. Ixx is equal to double integral y square dy dx. Now, how to write it? Double integral. Let's not put the limits now. X square minus r minus x whole square dy dx. Or we can even write y square dy by dx as integral y cube by 3. No, we'll write like this. Let us not. We'll go the way we have gone in the previous. Integral, and we'll put integral y square dy of dx. Then this will be integral. To remove the double integral, integral y square dy will be y cube by 3 dx. Now we know what is y square. Now we can understand what is y cube. Then this will be Ixx will be integral. What is y? It means y square is equal to x square minus r minus x whole square implies y is equal to x square minus r minus x whole square to the power of half. Y cube means 1 by 3, we will take it out. Y cube means x square minus r minus x whole square to the power of 3 by 2 dx. This is not x square, rather it is r square. Here also we will make it as r square. Here also we will do it as r square. When x is equal to r, then it is y is equal to r. When x is equal to 0, y is equal to 0. This is the equation whose definite integral has to be found out. That means Ixx of a semicircle with respect to x-axis will be integral 0 to 2r r square minus r minus x whole square, this whole to the power of 3 by 2 dx. I will give the answer. You take it as a homework. In the semi sine curve, I have solved this whole integral. Here, I will not be solving the whole integral. You please do it as a homework for you. I will give the answer. Ixx is equal to pi into r to the power of 4 by 8. You please solve it. Take it as a homework. Please don't neglect. Please solve it on your own. Take it as a homework. I have given the answer. You find out by solving this. Now, this is about x-axis. Now, what about center of gravity? Now, finally, we have to find out about center of gravity also. I, center of gravity. That is moment of inertia about center of gravity. Moment of inertia about center of gravity from the definitions, that is double integral y minus y bar whole square dy dx. Here, when we expand, it will be double integral y square minus 2y y bar plus y bar square dy dx. This will be I center of gravity is equal to integral and integral of y square dy minus 2y bar into y dy plus y bar square into integral dy and whole of dx with the limits 0 to 2r. This also I will little bit further expand this for your clarity. Integral 0 to 2r y square dy is y cube by 3 minus 2y bar into y dy is equal to 2y bar into y square by 2 plus y bar square plus integral dy is y bar square into y, this is dx, where y is equal to r square minus x minus r whole square to the power of half. That means ICG is equal to integral 0 to 2r y cube by 3 y bar y square minus plus y bar square y dx. This is the final equation which is to be solved for finding the moment of inertia about center of gravity, where y is equal to r square minus x minus r whole square to the power of half. Wherever y is there, you replace that y with r square minus x minus r whole square to the power of half, and using this equation ICG is equal to integral 0 to 2r y cube by 3 minus y bar y square plus y bar square into y dx. This also you take it as a homework. Do it in your home. I will give the final answer. Here you know the value of y bar. Y bar is equal to 4r by 3 pi. You can replace this y bar value in this equation. Y bar you know, y you know, and limits are known to you. Do it as a homework. Final result is ICG for a semicircle is equal to 9 pi square minus 64 into r to the power of 4 divided by 72 pi. This is the final answer. Try to get this final answer. Or this can also be written as b r to the power of 4 into pi by 8 minus 8 by 9 pi. The equations I have derived in the, if you have any doubts, you go back to my previous lecture on the sine wave, in which I have explained my previous lecture, that is channel civil mech maths concepts handle at civil mech maths video sine wave. Moment of inertia. This video will be moment of inertia for a semicircle. And I have given the playlists also in the video description. Playlist links are provided in this video description. From that you can browse to that. From CIVIL-MECH-MATHS concepts channel, you can go into this, and video sine wave movement of inertia you can find out. Otherwise you could not find out means playlist links are provided, from that also you can go. There are various playlists. GATE Engineering Mathematics, another is SSC JE, and there are 5 playlists are there. In any one of the playlists you will get. The links are provided in the description. Now, with this, I want to conclude today's session. Even though these exercises, remembering the values is easy, but finding them and understanding them is very much important. And if you understand the meanings, if you understand the derivation, you will never go wrong in the examination. It is with respect to x-axis. If that particular semicircle is kept with the base on the y-axis, what happens? That also you take it as homework. Find area, first moment of area, center of gravity, IYY, ICG, if semicircle base is on y-axis. Please do this as a homework. Playlists are, one is NCEES exam, first let me write this one. We can write either way. GATE Civil Engineering by IIT Alumni. Second playlist, SSC JE Civil Engineering by IIT Alumni. Third is GATE Civil Engineering by SSC JE Mechanical Engineering. IIT Alumni. I am writing in the chronological order of from old to new. Hence I have taken this order. Fourth is GATE Engineering Mathematics. Actually, this was the first. GATE Engineering Mathematics by IIT Alumni. Now, NCEES exam, PE exam, FE exam by IIT Alumni. Preparation with IIT Alumni. This is the playlist and channel is CIVIL-MECH-MATHS concepts, and my name is Ramchandra. I am thankful to you for listening to me. Thank you for listening to me and also viewing my channel. Please view, review, comment and subscribe to my channel. Subscribe to my channel for getting the regular updates. I will be regularly updating the videos. As per the syllabus, I will be doing the toughest ones first and going back to the easiest ones last, so that you feel very comfortable once you solved the tough ones early. The easy ones, you will not have any conceptual problems. Best of luck to everybody. It's again Ramchandra from CIVIL-MECH-MATHS Concepts. Please subscribe to my channel for updates. And I have released, this is the 52nd video. I have checked up till now. I have released 51 videos, the total videos, and it is the 52nd video. Please view all my videos, they will be useful to you, and review and comment on them so that I will be able to improve on the video making and also on the basis of the content you required. If you have any doubts, please write back to me on the handle so that you comment. I will reply to your comments. Thank you again. Best of luck to everybody in their examinations and even for working professionals. Thank you.